Okay, so today we're going to be looking at implicit slope. So far what we've covered is when we find derivatives, we're finding the slope, which is the change in y with respect to x, at a given point, and we're finding the equation of it. This is going to be implicit slope, meaning we're going to find the slope of an equation that isn't an equation that is written as a function, but maybe it's a shape, maybe it's something that is just non-functional. That's all implicit slope means. So we're going to go ahead and we're going to find the derivative, like normal, of equations that maybe not be written explicitly. But we're going to start out with the first one, which is an explicit slope, just to get the idea of what we're doing. We've already done something like this before. When we want to find the slope, well, slope is the change in y with respect to x, but at the given point, which means we are going to find the derivative of y with respect to x. The first thing that tells us is that we are finding the derivative with respect to x. So let's go ahead and do that. So if I take the derivative with respect to x, a couple things are going to happen. The first thing is going to be, well, the derivative of y is going to be 1 times dy over dx. The derivative of this is going to be negative 32x. And then the variables already agree. The change in x with respect to x, that's dx over dx. I don't need to write that term. Plus 32. Again, change in x with respect to x. Those cancel out. I don't need to write that. But here we go. Now, this is the slope. In fact, I can kind of ignore that 1 and just look at this as the formula for slope. And all we need to do to figure out what the slope is at that point is plug in our point of 2, 4. Anywhere where I see an x, plug in a 2. Anywhere where I see a y, plug in a 4. So dy over dx. I'm going to plug in my x value is 2. So let's see what we get here. So negative 64 plus 32. This is negative 32. And that is the slope at the given point. Not hard. We've done stuff very similar to this before. This is an explicit slope, meaning there's not really a whole lot done to the derivative other than it just gives you the slope. An implicit slope is when we do the same process, but instead of having y isolated, y is not going to be isolated anymore. This is a different shape. We have y as part of some functional aspect of the equation, squared. So let's go ahead and take a look at this. Now, with this, again, we're finding the slope, so dy over dx. Really all this is telling me is take the derivative with respect to x. So let's do that. So d over dx is going to imply that, hold on, let's come here, and let's do a little bit of u substitution. Let's call this a. So come down here for a. So if u is y plus 3, that means u prime is the derivative of this, which is going to be, let's see, 1, because the 3 cancels out, but it's also got a dy over dx. So f of u is going to be u squared. F prime of u is going to be 2u. So f prime of u times u prime is going to be 2 times y plus 3 times 1 of this, which is just dy over dx. Or 2y plus 6 dy over dx, and there's our value right here. So we have a 2y plus 6 dy over dx. And then over here on this side, pretty straightforward. It's going to be a 1. The variables agree. I don't need to do anything else beyond this. In fact, one of the things that you could do if you wanted to be neat and tidy before you went and plugged in your values, you could solve for dy dx. In this case, it's not too hard, so we're going to go ahead and do that. Not bad. There's the formula for the slope at any given point. What point? Well, 14, 1. So let's go ahead and plug in those values. In this case, I'm going to plug in the value of y, which is 1. So I get 1 over 2 plus 6, which is 1/8. Boom. And there we go. So not too bad. The process of implicit slope is just finding the derivative with respect to x. And we're trying to end up, when we solve all this, we're going to find dy over dx. That's it. So when we're given something a little more complicated, we just do the same process we've always done. Now, this looks like this would be a fun little chain rule to go ahead and follow, but what we've also covered previously is we can simplify this using logs. So let's go ahead and take the logarithm both sides and see if we can't simplify this a little further, so we don't need to do so much of these subroutines. So I'm going to say the natural log of 3x squared plus y squared squared equals the natural log of 100xy. Okay? So I know that when I multiply two terms within a log, I can separate that into the log of 3 plus the log of this. But when I take the log of this, I'm immediately going to try and pull out, let's not do this in red, let's do this in purple. I'm immediately going to pull that 2 out to the front. So I'm going to add the logarithm of this, but I'm already going to have pulled out the 2. So natural log of x squared plus y squared. Boom. So got the log of both of those. And again, I have number times a number times a number, or something times something times something, which means log of 100 plus log of x plus log of y. And when I say log, I should be saying natural log, but I think we get the idea at this point. This is a much easier derivative to take, albeit we took something that was small and concise and kind of blew it up here, but it's going to be much easier to work with because of a couple reasons. Now we know we're finding the slope, so we're taking the change with respect to x, which means any constants, that and that, are just going to disappear. We're really only taking those. And this is the only one where we really need to do any sort of quick process. But we've already realized that when we're given this form, a natural log of u, it's going to be a times u prime all divided by u. So we don't really need to do too much right there. We can just go ahead and take the derivative. So if it's going to be a u prime, let's do this in black. So it's going to be 2 times the derivative of the interior. It's a polynomial, so I'm going to take 2x, variables agree, plus 2y, variables disagree, so dy over dx, all divided by u. So x squared plus y squared. Boom. No need for a chain rule there. Here, that's going to be 1 over x, variables agree, plus 1 over y, variables disagree, so dy over dx. And now, at this point, it's going to change slightly from what we did in number 3. On number 3, what we tried to do first is we wanted to go ahead and isolate this dy dx and combine that. Now, this looks like it's going to be very messy to do so. So why don't we just go ahead and skip that process of isolating what is the formula for slope. We don't need to find the formula, we want to find the slope. So let's just go ahead and plug in our 3, 1. So 2 times and anywhere where I see an x, plug in a 3. Anywhere where I see a y, plug in a 1. Boom. And remember, what we're trying to isolate is the dy dx. So now that we've got just a bunch of constants, let's just simplify this as best we can. So that's going to give us, let's see, 2 times 6 plus 2 dy over dx. Let's see, 3 squared is 9, plus 1 squared is 1, so 9 plus 1 is 10. 1/3, that's going to be a 1, so it's just dy over dx. I'm going to go ahead to get rid of this fraction. I'm going to multiply that side by 10, and I'm going to distribute this at the same time. So 12 plus 4 dy over dx equals 10/3 plus 10 dy over dx. Now it's all just simple algebra at this point. I'm going to move that 10 over here. So 4 dy over dx minus 10 dy over dx is 10/3 minus 12. As a side note, we know that that 12 is going to be the equivalent of 36/3. So it's 10 minus 36/3. It's going to be negative 26/3. 4 minus 10 is going to be negative 6 dy over dx. Divide both sides by negative 6. Actually, let's spiral that up right here. So dy over dx is negative 26. That's going to be a negative 18. So negative 26 divided by negative 18, which is 13/9. There's our slope at that point. And so albeit there was a lot of arithmetic and a lot of algebra going on right here, the process isn't bad. If you can simplify it using logarithms, do so, but ultimately you're finding dy dx. And if you can, like in number 3, isolate that, you've got a formula, that's awesome. If not, if it looks too complex, you don't need to do that. You can just go ahead and plug in your value and solve right there. So now that you've seen a couple examples, why don't you pause the video, try out number 7, unpause it when you're done, and see how well you did. Okay, so let's take a look. We've got a pretty simple formula right here, so it's not going to be too bad. I know I want to find the change in y with respect to x because that's going to give me my slope, which means that I'm going to take this equation and find the change with respect to x, which is immediately going to cancel out that 9. And we know that canceling that 9 is going to leave a 0, but I'm not going to write that until I'm done with the left. So that's going to be 2x, the variables agree, plus 2y, the variables disagree, so dy over dx equals 0. And so again, like we did in number 3, I could isolate this if I wanted to. I don't need to, so it's whichever is your decision. If you want to isolate that and get a nice little formula, you can, but it's not necessary. I think I'm going to do that, just because why not? If I subtract the 2x, so negative 2x, and then divide by 2y, I get my dy over dx. The 2's cancel out, so dy over dx is going to be negative x over y. So I just went ahead and solved for the formula. You don't need to do that. You could just plug in your values. But I know that I have the same value, and it looks like I'm dividing those two, so this should be fairly quick. I have 3 squared root of 2 over 2 divided by 3 squared root of 2 over 2, which we know is going to cancel itself out. So dy over dx is going to be a negative 1. And there you go.